Data science is 40% coding and 60% storytelling. When you present your analysis, you aren't just showing a plot, you are telling them a story through your findings. Today, we are going to look at how t-SNE and UMAP convert columns of data into beautiful data visualizations, transforming black box machine learning techniques into understandable, visual narratives. Let's master the art of the data-driven slide deck using these advanced visualization techniques. But wait, what are t-SNE and UMAP? They are nonlinear dimensionality reduction techniques used to visualize complex, high-dimensional data in 2D or 3D plots. You may think of them as data visualization techniques to easily identify clusters of data. t-SNE stands for T-Distributed Stochastic Neighbor Embedding and UMAP stands for Uniform Manifold Approximation and Projection. t-SNE works by converting high-dimensional Euclidean distances between points into conditional probabilities representing similarities, then finding a low-dimensional embedding that minimizes the Kullback-Leibler divergence between the high and low-dimensional distributions. On the other hand, UMAP assumes data is uniformly distributed on a Riemannian manifold and uses local metrics to approximate the manifold structure. So how do they compare against each other? Well, firstly, t-SNE focuses on preserving local relationships, meaning it tries to keep similar data points close together in the lower dimensional space. This allows it to form tight, well-separated clusters. However, since it doesn't really preserve global relationships, it means that you are not able to compare different clusters. On the other hand, UMAP provides a better balance between local points and global relationships, maintaining meaningful relationships between clusters and global structures. t-SNE is slower, while UMAP has faster computation and handles large datasets better. So what situations do we use them in? Use t-SNE if you are focusing solely on cluster separation and the dataset is relatively small or medium size. Use UMAP if you have a large dataset, need to preserve global structure, or a faster computation speed. A note of caution here, regardless of t-SNE or UMAP being used, they are only useful for data visualization purposes to see clusters, and should not be used for actual clustering. Clustering should still be done using machine learning clustering or segmentation techniques. Now, we can move on to code in Python. As always, we start by importing the libraries we need to use for this code. Next, we will import a dataset from Kaggle that will be used for our data visualization. This time, we will use the Marmara sea fish species dataset. This dataset is interesting, as there are 10 different types of species, and it is a synthetic dataset that mimics real-world ecological data with natural class imbalance, where there are some species that are more abundant in nature, and there are some species which are rare and fewer in existence. We can output it to a data frame and inspect the data. We can see that there are 6 features, which relates to the body characteristics of the fishes. They are the total length, body depth, width, head length, eye diameter, and the weight of the fish. We can take a closer look to see if there are differences between the species of the fishes by viewing the summary statistics grouped by the fishes. First off, we can see that there is class imbalance from the count column. Next, looking at the section for total length and weight, we can see a mix of variability in terms of the numbers across the different species, though there are some which seem to be similar. But generally, there is variability in the data, which should help in visualizing clusters of the fish species. As the column features are in different units of measurement, we will apply a standard scalar and transform the data before using t-SNE and UMAP. Now that the data is prepared, we can initialize the visualization objects. We shall start with instantiating the t-SNE object and fit and transform the scaled data, compressing to a 2-dimensional form. Once done, we can plot a scatter plot to visualize the data grouped by species. Voila! We have a beautiful looking chart. We can see that fishes of the same species are generally clustered together, with some clusters separated nicely. However, do note to not put too much emphasis on the separation, as t-SNE doesn't take global relationships into consideration, And rather than thinking that the clusters are differentiated and distinct from each other, we can think that the in-cluster samples are closely related instead. Do note that for t-SNE initialization, you will get a different scatterplot for each visualization. You can try it out yourself to see which is the best scatterplot. Next, we can do the same for UMAP. We will instantiate the UMAP object and fit and transform the data. Similarly, we can plot a scatterplot in 2 dimensions, and the first thing we notice is that it is shaped very differently from the t-SNE plot. This one looks more like an archipelago. Similarly, we can see that fishes that belong to the same species cluster together, with somewhat similar clustering to the t-SNE plot. However, for UMAP, the distances between the clusters do indicate a distinct difference between them. Notice that the clusters are not as well defined compared to t-SNE, and that is probably due to the fact that the clusters are more similar to each other. To conclude, both t-SNE and UMAP are good tools to use for data visualization, especially for presentation to management where they may not understand data science and data analysis. Just take note of the difference between them and how the plots are formed, and apply the use case for them accordingly. For those who are interested, I will be sharing the link to my notebook in the description section of the video. Do you have any thoughts on it? Feel free to comment in the comment box down below. If you liked this video and would like to see more content of this nature, please be sure to like and subscribe as well. Thanks for watching, and until next time.